Assalamu alaikum. This is another class on measurement. क्योंकि हमें के का बेस यूनिट निकालना है तो हम क्या कर रहे हैं कि पहले इसको रीअरेंज किया मैंने। दूसरे पार्ट के लिए आप इसको रीअरेंज की हुए फॉर्म को यूज कर लें। Data for a particular satellite are given in the figure and calculate K and its actual uncertainty is required.
For the above part, was it coming kg s square m minus 3?
You can check it.
Yes, I'm getting the same answer.
Good. So now you can see that this is the equation and we have the values in our hand and we can put them. First, you show examiner that you are putting the values. After that, you can put the equation, you can put the values of the equation directly. Power always comes in advance.
I'm getting A as 5.9 into 10 power 11.
5.9.
10 power 11.
I have shown the rearrangement. And then you have to put the values d by t upon t. Now here I can use directly the percentage.
Don't we have to put the actual value of like T, M, and R?
I don't find any benefit because when I will divide it, I will get the same percentage again, because percentages are in a ratio 0.5 upon 100. So if I find the percentage of t, 0.5% of t, and divide it by t, I will get back 0.5.
So can't we do like 0.5 over 8.64 into 10 power 4? Or we have to
No,
take 0.5 over 100?
because it will be the same value, no? If you do 0.5 upon 100 into 8.64 10 power 4, you will get only deba t. Then you'll divide it by deba t. So 8.64 part will cancel out. Now you have to first copy this working and then you have to calculate it.
I'm getting 0.06.
0 point. That's all. 0.0. What
No,
about the
for the first part, and then for the second multiplied, that's 3.54 into 10 power 10.
you're giving the 3 point?
54 into 10 power 10.
10 power 11, na?
No, 10. 10 power 10.
Oh. So try to shift it, make it 10 power 11. Because the other value is 11, and we have to write it together.
So 0.354.
0 point. Okay, and then we round it.
One significant figure. So
Yes.
0.4.
We can make it 0.4. A coin is made in the shape of a thin cylinder as shown. Density of the material. Calculate the density. It's a cylinder shape. Density is equal to mass upon volume. And how we now adjust this diameter issue? Because we always tell students that do not alter the value, because that will affect the uncertainty. Try to rebuild the formula. Mass is 8.6 gram. Answer is coming in kg. So 8.6. Diameter is 22.1. Millimeter, and height would be thickness 2 millimeter. So we have shown all the steps, and now we can put the data to get the values.
It's coming as 13.8.
You're saying 37.8.
13.8.
Calculate the percentage uncertainty in density. We have the formula. For uncertainty, we do not consider the constants.
Why did we multiply the mass by 4? I didn't take that in the calculation. I think that's wrong.
Acha, because 4 was in the denominator, na? So mathematically, when you move it, it will go up. Four was in the denominator.
Now it's coming as 55.3.
$55.3. Okay. Deba M upon M. 0.5 upon 9.6. 0.01 upon 2. 0.1 upon
The 0.01 over 2 will be multiplied by 2. Like because
sorry, I missed it. You're right. 0. Right. So you have to multiply this. You have to multiply this by 2.
and we don't need to place the value of 55.3 right now, right?
Yes, because we are getting the percentage directly.
So it's 6.66.
Sorry.
6.66%.
State the value of density with its actual uncertainty. Now we have to get it in that form. Now we have to combine it. So we have to multiply 6.66 with that number. Now we should remove the 100, and before 100 we had a value. We should have a value of 0. 0.066, right? So we multiply by 55.3. We need the absolute uncertainty, no?
So we can do 55.3 over 100 into 6.7.
You can do the same, but you can also do it like this. So this will give us the uncertainty.
It's coming as 3.7.
This number is coming a bit bigger. 4. I think we should check the answer June 14, 22 too. Anyways, the values are fine up to here, but uncertainty is coming a bit high. 3.7. Pressure is equal to force upon area. A cylinder is placed on a horizontal surface as shown. The following measurements were made on the cylinder. Mass is given and diameter is given. Pressure produced by the cylinder on the surface. Pressure is equal to force upon area. Area is a round shape, circle. So I can take it like this. The area of now if we move the 4 up,
Will we convert the centimeter to meter first and then do it?
it's fine because diameter is in centimeter. Answer is coming in Pascal. So we need to convert it, right? Mass is fine.
I'm getting 7.4 into 10 power 3 Pascal. 7.2 into 10 power 3.
7.2 into 10 is to power 3.
Yes.
Calculate the actual uncertainty in pressure
So when the values are given like this, we can take the actual values, and when the percentage is given, we can just take it as a fraction of 100.
Percentage can be tackled directly. As mentioned, we can ignore the constants. So I have made the equation. State the pressure with its actual uncertainty. First, you find the uncertainty in pressure and let me know.
It's coming as 0.3 Pascal.
0.3.
I'll check again. It seems to be small. Yes, it's 167.3.
Sorry,
167.3.
the uncertainty.
The actual uncertainty.
But you told me 7.2. Actual uncertainty can't be so high, Ali.
Because I did it again, the calculation. First, it was coming very small.
But this is so big, even it's what number you said?
167.
167.
Maybe because the pressure was also very high, like 7200.
167.3. Now, how we balance it? We have 7.2 into 10 power 3. So either we can write it 7200 A microphone detects a musical note of frequency F. The microphone is connected to a CRO. The signal from the microphone is observed on the CRO. A microphone detects a musical note of frequency F. The microphone is connected to a CRO. The signal from the microphone is observed on the CRO as illustrated. The time-based setting of the CRO is 0.5 millisecond per centimeter. Y plate is 2.5 millivolt per centimeter. Use figure 2.1 to determine amplitude of the signal. Amplitude is actually the height of a signal. Now, we can say there are how many divisions? It's being clever. He has given one small box extra. Two divisions are complete. But what about this little extra box? How to tackle that?
We'll take it as 1/4 of the original value.
Because this is a problem na, that actually there are 5 divisions in 1 centimeter. There are 5 divisions in 1 centimeter. So there are 2 centimeter complete, but there is a one small box. Should I take 2.1 or how should I manage it? 1 cm for 5 division. 1 centimeter means 5 division here. So I have total 11 divisions for this amplitude. So if I take 11 division, how much x would be there? You can find x for me here.
X is coming as 2.2 centimeter now.
So the scale is 0.5 millisecond per division.
It comes as 1.1.
Oh, yeah, so sorry. Actually, I took by mistake the scale of the x-axis. Actually, amplitude is on y-axis, na? So I should have taken y-axis scale. So quickly correct it.
Now it is coming as 5.5.
The frequency can be either done by time period approach. If we see if we can find the time period. This is one cycle. We have to see how many little boxes I can count here. Again, that 1 cm is 5 division. So I have to see how many little divisions are there, little small boxes are there.
I'm counting 20 boxes.
20 boxes. So it's coming 4 centimeter and the scale is 1 cm for 0.5 millisecond. Frequency is 1 upon time period.
It's coming as 500.
Find the actual uncertainty in frequency caused by reading on the scale. Now you have to see if any uncertainty value is given. I think we have to verify our reading first because I was thinking how it can be 4. because it's one division less. Can you see the time period working again? And it's precisely one division less. So can you help me to check that? Was it 4 or was it less than 4? Are there
A
20
bit hard
boxes?
counting on the screen because I can't mark them.
But you can see the time period barrier which I have made. It's one division before 20.
So then it will be 19 then.
I think you can see now it's not 4. Actually, is 19 division. So we should correct it. Now, can you see how much it would come now?
It's coming as 3.8 now.
How much it would be? 3.8 into 0.5.
1.9.
Now, how much would be the frequency?
It's coming as 526 hertz now.
The actual uncertainty in frequency caused by reading the scale on the CRO. Uncertainty is in our measurement. Uncertainty should be considered as the least possible error. When you are reading a scale, the scale is now visible to us.
Is it 0.01?
No, you have to first see how much error you can find in reading. In 3.8. So we have to remember the rule that uncertainty, if there are 20 divisions, 20 divisions means 1 centimeter. Half of the least count. What is the least count of this scale? Our least count is 1 cm. And 1 cm So there's a possibility of 5 division in 1. So it's 1 upon 5. So 1 division is 0.2. So the least count is the minimum number we can read is 0.2. The error would be plus minus 0.2. 5 division for 1 cm. If you can, I think you can see this one on the graph. So 5 division for 1 cm. If I take the least count, 1 division so we have an error of 0.2. That is the minimum we can take. Our distance was 3.8. We can take the percentage error. So make a percentage here.
It's 5.3%.
So we got the uncertainty in our source. He's asking for frequency. So find this percentage because we need the error in uncertainty in frequency.
It's coming as 28.06.
Twenty-eight point zero.
06. It will be taken as 30.
You can
Uh,
no, it's not. You can leave it here in the final answer because uncertainty should be given to correct to 1 sig fig. When examiner says actual uncertainty, you can write it in more than 1 sig fig. But as a rule, I always tell the students to show your initial working and round it to 1 sig fig. But when he says write down the final uncertainty, then it should be 1 sig fig. So this is an issue, and for uncertainty in that, it's always a concern when you are dealing with uncertainty. The answer should be correct to 1 sig fig. So we have done this work, and as our series of topical work, we have improved some work in uncertainty. This is a very simple topic, but many small issues, just like we had a chance to discuss the issue of uncertainty from a graph. So we did it up till here, and we will inshallah continue this work in our tomorrow class. It's over for today. We will do it inshallah in our next class. Allah Hafiz.
Allah Hafiz.